In this video, I'll show you some of the basics of differential equations. We've already been working with differential equations. You spent a couple of weeks at the beginning of the semester working with and interpreting these equations. In this case, S prime of t is the rate in people per day at which the number of susceptible people is changing. One of the important things to notice is that the rate at which the number of people is changing depends on the actual number of people in the population. That is, S prime of t depends, in part, on the value of S of t. Another important thing to notice is that the rates of S prime, I prime, and R prime change over time. So even though the units are in people per day, the rates, the values of S prime, I prime, and R prime, will change over the course of each day. This leads us to a general notion of a differential equation. A differential equation models a situation where the rate of change of a function depends on the value of the function. Symbolically, this looks like f prime of x is equal to some equation involving f of x, where the f of x might be multiplied by some stuff and you might add some other stuff to it. Another example you worked with, even though we didn't write it explicitly as a differential equation, was half-life. Specifically, you looked at iodine 123, which had a half-life of 13.2 hours. So, for example, if you started with 100 grams of iodine 123, then after 13.2 hours, you'd have 50 grams left, and then another 13.2 hours later, you'd have 25 grams left, and then another 13.2 hours later, you'd have 12.5 grams left. And if you looked at the average rate of change of iodine with respect to time over each 13.2 hour interval, the rate of change is going to be equal to -1 over 13.2 times the amount of iodine, I of t. And you can see this in these average rates of change formulas that we computed here. So even though we just computed these values for average rates over these long time intervals, this equation would actually work for any point in time. So in particular, the rates of change are changing constantly from hour to hour, minute to minute, and second to second.